losing, leaving right when the snowstorm hits. There are exceptions to having a big 50-50 low and then no 50-50 low getting a snowstorm. So you have to understand how everything works together. So there's going to be this complex matrix on the website when the snowstorm checklist is up. I'll go over it a little bit here. NAO. Well, again, I was going to have a nice graphic here, and I had it in the old. Anyway, it's a long story. Special rule number 1: the CPC or the ERL forecast is 7 days out, 10 days out, 14 days out are almost useless, even if they're accurate in forecasting the NAO phase. Now, why is that? Because it's not the NAO phase that we're looking at. All right, you can look at it for the phase, but that doesn't mean you get the patterns favorable for East Coast snowstorm. And the reason for that is because the definitions that are used for the NAO includes having the big ridge sitting up over Iceland or the UK, and that counts as a negative NAO. Not for East Coast snowstorm fans that don't. So as a result, the definition is different. We're looking for a specific type of a negative NAO here, not the textbook classic, which meets the conditions by CPC, which really doesn't give a rat's behind about northeast snowstorms, because it's not the time. So that's one of the reasons why. The definitions have changed a lot in the last several years. It's position and intensity, and in regard to the NAO, we're looking just for significant East Coast snowstorms, major East Coast snowstorms, historical ones. That's what we're focused on. So, okay. Nope. There. NAO. Special rule number 3, there are several types of NAOs, events. There's the eastern one, when you've got your block, or block or ridge, and 500 millibars sitting out over Iceland, the UK. Those are hostile conditions. They do not support, that's not a favorable pattern. You'll look at that CPC chart and see, go way down in there, folks up in State College might be saying, wow, that's, if it's out by Iceland, no, they ain't gonna cut it. Greenland block, that's the classic position. Davis Straits, that's what you want to see, the Davis Straits, that's good. And then there's the western position, Labrador, Quebec. You see that, you start doing the snow dance. Okay, because that's a good position. And then snow dance, I'll show that to you later on. So, and then finally, the other thing which is important, we've seen this several times the last couple of winters, the North Atlantic thumb. You see that little thumb ridge which sticks up in the North Atlantic as it approaches Iceland? All right, and that doesn't cut it. That's a thumb ridge. That doesn't help. That may technically qualify as an NAO because the heights may go above normal in southern Greenland. Again, that doesn't help us for East Coast snowstorm. Carp. I meant to say carp there. All right, downstream blocking. The NAO does not have to stay negative through the whole event. Okay, we all know that from when Heather's presentation a couple of years ago at one of the conferences, which I presume most people saw. And her research, as I mentioned many times, Tips talked about it, and I think Gus has talked about it. But it's best if it does stay negative the whole event. Ideally, you want to see the negative NAO stay the whole event, because what happens is after it happens, you usually get a cold outbreak, and it stays really cold, and people are, it's the end of the world, and the media goes crazy. So that's always fun to watch. But that's at best if it does. It doesn't have to do that to keep it. Okay, but the NAO can shift to neutral, especially if it's been like 24 hours or 12 hours before the event or at the time of the event, especially if the NAO has been sustained. So again, if you're looking at a really negative NAO and begins to move towards neutral at the start of the event, as the event develops on the East Coast, that's good. You like that. Now that phase change, as we talked about with Heather, has talked about many times before, that's something you want to see. We saw the President's Day storm in 2003. We saw that in January 2000. Those are classic recent cases where the NAO went through a phase change as the snowstorm was developing on the East Coast. So that's pretty good. Science. It works. NAO. Let's see. Without the NAO, you're likely to get the dreaded coastal track, or the inland runner, or an Appalachian track become much more likely. Not certain as a tendency for without a negative NAO. You can get it. There are exceptions to that, but there's a general tendency for that. And again, with the NAO, the further west it is, the better, and especially for the mid-Atlantic area. For the further east it is, the worse it is. That's the basic overriding principle of the NAO, as far as East Coast snowstorms go. The 50-50 low. Well, there are 3 types of 50-50 lows. There's your intense close 500 low, where you see that low sitting over Newfoundland. Everybody know what a 50-50 refers to. I'll go over the position. 50 degrees north latitude, 50 degrees longitude. All right, that is Newfoundland, Canada. Some people call it the NF low, but we don't want to give the Canadians any more glory than they already have. So, the intense close for 50-50 low, that's a best. Okay, you want to see that low sitting over with lots of contours around it. That's really cool. The surface map, you may see like a 964 low, something up by Newfoundland or just east of it. The upper levels will have many contours around 500 millibars. If failing that, a closed 500 low, where you've got one or two contours around it. That's nice to see. That's also very good. And then finally, you can have a open short wave just moving through Newfoundland. That's okay. It's not horrible. It's not great, but it's okay. And this is the schematic again from Paul's. This is the classic position, and this is why the 50-50 low is so important, because the black lines here show you your upper air features, right? So there's your 50-50 low over in Newfoundland, Canada. And this is, here's your trough coming in here, your phasing troughs coming in that way, all right? And this is the black lines here show your confluence zone. So what happens is the 50-50 low builds that confluence zone and essentially blocks the high from leaving. So as a result, the high stays in the right position and you've got your permanent fresh supply of cold air. Without a 50-50 low, what happens is the storm comes up this way and the high continues moving because there's nothing to block it. So it continues moving and you lose your cold air. And the classic case of that was the President's Day storm, which turned to ice a little bit. The numerous cases like that. All right, the 50-50 low, again, what it does is it keeps the cold air in place. It sets up the confluence zone of the Great Lakes, New England. It strongly favors big 50-50 lows, the track being the classic snowstorm track, the big ones there. It favors phasing and split flow patterns, and it favors also the neutral and negative tilt. So, doesn't guarantee it, favors it. Right. The polar vortex. It's on, the thing about the polar vortex is it's always a clue. Unusual or displaced polar vortexes are always a clue about what's going to happen. So you'll see maps. Again, I was going to show you some of these maps, but I couldn't. The super intense polar vortex. When you see this polar vortex, it's sitting up there in Canada with all these contours around it, 474 decameters, really intense suckers that's sitting up there. That's actually hostile for East Coast snowstorms. Now, why is that? Because what you want is, remember, you want to see that northern branch drop into the southern branch. You want to see some sort of phasing, right? You've got all these contours around it. What does that mean the winds are doing? That means the winds are howling around that vortex, which means you can't get buckle in the northern stream, which means you don't get phasing. So that's why you've got a big vortex up in Canada with like 5 or 6 contours around it. It's really deep. That's not favorable for East Coast snowstorms. Now you can still, again, that doesn't necessarily rule out getting a significant East Coast snowstorm. I'm talking about the big one. And you can still get some sort of wave development, but explosive development is not likely to happen. Special rule number 2, a southern displaced polar vortex favors the mid-Atlantic region, assuming the displaced vortex holds it's not overdone. Sometimes you'll see the models show that the vortex coming out of Canada and sitting like over Lake Huron, and people are all excited about that. It's very impressive. Then what happens is that the model's coming back off of that. So we want to make certain that the vortex does in fact get that far south, because when the models are showing something extreme like that, you want to make certain it's the right solution. So you don't want to get too wild, but that's generally, if that holds, that's actually good for the mid-Atlantic states. And then a southern displaced polar vortex that's also intense can actually act or counter as a pseudo 50-50 low. Did I spell pseudo right? Amazing. Yeah. The medicine is working. Okay. So, and what it does is that keeps the confluence zone in place. So that's the advantage of having displaced polar vortex. When it comes down out of Canada and you see it parked over Lake Huron or Messina, something like that, that will, of course, what that does is that pushes it, develops a confluence zone because it's placed to the south. So you're still having your height lines moving across the Great Lakes, New England, and you're still having your confluence zone there. So it acts as a pseudo 50-50 low. So that's